ferromagnetic materials are those that have the most magnetic properties. So what does that mean? Well, you know that all things are made of tiny particles called atoms, right? In metals like iron, there are many groups of atoms. Within each group, the atoms are all spinning in the same direction. Each of these groups is called a magnetic domain. Imagine these umbrellas are atoms. If all the atoms are spinning in the same direction, they form a magnetic domain. Each domain is like its own tiny magnet with a north pole and a south pole. The key to magnetic power is how the domains behave in a magnet, or in any piece of metal for that matter. In a magnet, all the domains are lined up in the same direction. When a ferromagnetic material, like this metal fridge door, is placed in a magnetic field, like a fridge magnet, the poles of the magnetic domains in the door are attracted to the opposite pole of the magnet. Here you can see how the domains near the magnet line up, all the north facing the same direction, and all the south facing the same direction, just like in a magnet. The attraction is so strong, the magnet is held to the door. Luckily, the force of magnetism even works through a piece of paper, so you can stick notes to the door. Something I didn't realize is that there are not many naturally occurring magnets. The first ever known and the most common is a mineral called magnetite, or lodestone. It was discovered more than 2,000 years ago, way before anyone had any idea about magnetism. You may have noticed that when you stroke a piece of metal with a magnet, it becomes a magnet itself, for a little while at least. The reason a regular piece of metal can act like a magnet is because of domains. Remember, when a magnet touches a ferromagnetic object, the domains all line up in the same direction, just like the magnet. When the magnet is removed, the domains in the metal will return to their normal random pattern, but it takes some time. While the domains are lined up in the same direction, the metal acts like a magnet. This is called a temporary magnet. How long a temporary magnet stays magnetic depends on the type of metal it is, and how strong the magnet was that it came in contact with. Some metals, like iron and paper clips, are easy to magnetize, but they lose their magnetic force pretty quickly. Other metals can be made into magnets that last a long time. These are called permanent magnets. The domains in these magnets are all lined up, and they're very slow to return to a random pattern. Even a permanent magnet can be demagnetized. If you drop a magnet repeatedly on the floor, the magnetic domains actually can be knocked out of alignment, weakening the magnetic force. So magnetism is based on magnetic domains, and domains are based on spinning atoms. Got it. But what does spinning atoms mean? These swimmers will help us visualize an atom. The center of an atom is called the nucleus, played by the swimmers in the white caps. Around the nucleus are a number of tiny particles called electrons, played by the folks in the blue caps. Here's a more traditional drawing of an atom. When we say that an atom is spinning, it's the electrons we're talking about. They constantly orbit the nucleus of the atom, and like we said earlier, it's spinning atoms, more correctly their electrons, that create magnetic domains.